Hi, my name is Allie Wilkins, and I'm a fourth-year architectural engineering co-terminal degree student. And this semester, I participated in the Digital Twin IPRO. So what exactly is a digital twin? A digital twin is a 3D representation of a shape, object, or space. For our projects this semester, we used LiDAR scan technology to create digital twins of buildings on the IIT campus. As a group, our semester goals were to finish 2 buildings that had been started last semester, Alumni Memorial Hall and Retaliata Engineering Center, also known as E1. Personally, my semester goals were to expand my knowledge on the many benefits and uses of digital twins, learn more about the softwares and technology needed to create these models, and also learn how to manipulate and merge point cloud data. This is just a quick list of the applications I learned how to use this semester, and I'll be going over each one in a little bit more detail. Sitescape is a free iPad iPhone application that uses LiDAR scan technology to create a 3D representation of a desired shape, object, or space. There are multiple density and quality options for taking scans, and for our purposes this semester, we decided on low quality and low density scans. These scans worked the best when compiling them all together in Cloud Compare, and the files were small enough for our personal laptop computers. In Cloud Compare, I was able to upload multiple point clouds in order to move them around and merge them together to create a room or a set of rooms in a building. Due to the size of the rooms in the 2 buildings we were in charge of scanning, it was almost impossible to get the entire room in one point cloud scan. Therefore, merging was necessary at all points or at all stages of the project. In order to complete the master files of the building, we needed to merge our new scans with the existing files. Sitescape has a really handy feature that allows for geolocation inside the point clouds it produces, which means sometimes when we upload the point clouds to Cloud Compare, they're already pretty much in the right spot. They don't need a lot of moving around, and that makes merging the 2 files a lot easier. Autodesk Recap was really helpful in creating virtual walkthroughs of our completed building scans. Once we were able to merge our point cloud scans, we uploaded the master file to Recap and took some 3D virtual tour videos. The Capture app that's offered through Matterport was our main inspiration for where we wanted to take our project this semester. The free version of Matterport allows for one active space at a time, which was perfect for getting the data we needed and trying out all of the different tools the program has to offer. Matterport combines LiDAR scan technology with 360-degree photographs to create a Google Street View-like image of the space. This tool is mainly used to keep progress updates of new construction projects. In the 3D scans, users are able to take direct measurements, tag items with their project data and links, walk through the space at each scan location, and also add labels and notes to the files. These tools eliminate the need for the project members to physically visit the site throughout the project lifecycle, which saves a lot of time and money, and we all know how important those 2 things are. Here's just a short example of taking scans using Sitescape. Each of the 6 scans shown here were between 1 million and 5 million points at the low density, low quality scale. Here I have an example of using Cloud Compare to merge and clean up the point cloud scans. You can see in the image on the left, there's some floating point clouds or some floating points outside the area I had intended to scan. These come from the reflective surfaces skewing the LiDAR technology and also from the windows and glass surfaces that the LiDAR technology cannot pick up. I used the trim and segment tool in Cloud Compare to get rid of these floating points, and it just makes the scans look a lot sharper. This is an example of scans taken of a classroom in the basement of the Retaliata Engineering Center using the Capture application in Matterport. You can see the Google Street View-like pictures on the left, and on the right is a rough floor plan. Each number is where I stood to take a 360-degree scan of the space. Matterport combines all of the scans of the same space to make one big file that you can walk through using the same locations that I stood to take the scans. This is an example of the tagging feature in Matterport. Once the scanned file is uploaded to the Matterport browser, users can insert product links and other data into a tag. The tags can be color-coded and categorized to fit the user's needs. Our final application as a team was to create a software similar to Matterport that allowed for measuring and equipment tagging, but with the raw point cloud data instead of the 360-degree photo display that Matterport provides. So what did I learn this semester? What is a digital twin and why are they useful? Digital twins allow for real-life data. You can take area measurements and collect product inventory in the digital twins instead of just relying on a Revit model for the correct measurements. What is a LiDAR scan technology and how does it work? LiDAR scans create 3D point clouds of a shape, object, or space by sending out signals and creating an image based on the received data. LiDAR works both with and without light. The color in the Sitescape application comes from the camera portion of the scan technology. So technically, LiDAR scans do work in the dark, but all the points that come up on your 3D model will be dark. How can multiple scans of the same space be combined? Using Cloud Compare, point clouds can be manipulated and merged together through the geographic tagging location from the Sitescape application and also manually using the Cloud Compare tools. What is Matterport and what tools does it provide? Matterport is a 3D scan technology platform that allows users to capture multiple 360-degree LiDAR scans along with photographs of a space. Tools include virtual tour creators, dimension and measurement rulers, trim tools, and product tagging tools. Users can tag products with their data and include links to data sheets or maintenance logs. Users can also take direct measurements of the provided images, which eliminates the need to physically visit the site or space to collect the data. This type of technology is only going to grow and become more popular, and I'm so grateful to have been introduced to it this semester. Thank you.